Guys, welcome back to the AI Explained series. I'm so happy you are here today. If you watched part 1, you already know, right? What artificial intelligence is, what machine learning is, and the difference between AI, ML, and deep learning. If you haven't watched that video yet, please go check it out first and then come back here so that you will have better clarity when you watching this, right? Yeah, so before we jump into the machine learning types, I wanted to share a couple of things. So I would say AI is already part of our world, and instead of seeing it as something to avoid, we can embrace it and find a ways to use it thoughtfully. It's all about working with AI, guys, rather than feeling like we have to run from it. I would say, like these days, mobile is part of our body, right? Yeah, I would like to say AI is also same. Moreover, we have recently seen what Oracle Corporation did around 18% of their employees. Their main focus is to invest heavily in AI, which has resulted in layoffs. This is obviously heartbreaking and scary news for everyone. Over the past 2 3 years, we have witnessed many layoffs, right? I think it started gaining attention with TCS, which has quite shocking at the time, and now the latest news from Oracle continues that trend. So yeah, let's get started with our machine learning types today. So we are going to go one level deeper inside machine learning. We are going to explore two of the most important types of machine learning: supervised versus unsupervised learning. In fact, there is one more type, reinforcement learning, so that we will cover up in the next video. Uh, I think for few people it might, sound like overwhelming, but yeah, we have to learn. So yeah, whatever we need to adapt, guys. So these two concepts are used in almost every AI product you use daily, right? From Gmail spam filter to Netflix recommendations to your bank's fraud detection system. Yeah, by the end of this video, you will completely understand how they work, what the difference is, and when to use each one. And I would say this video is perfect for complete beginners because no coding, no math, just clear and simple explanations with real life examples. So let's get started. Yeah, just before we jump into this today's topic, let me do a very quick recap from part one. Machine learning, which is absolutely subset of AI, can be divided into three main types. The first type is supervised learning. In this type, the model is trained using labeled data, meaning someone has already given the correct answers. Think of it like a student studying with a textbook that has answers already filled in. The model learns from those answers. The second type, unsupervised learning. In this type, the model is given raw data with no labels, no answers. The model has to explore literally on the data on its own and discover hidden patterns. Think of it like a detective. No clues are given. You have to figure it out ourselves. The third type is uh, which is, like I said earlier, a reinforcement learning. This is very different. The model learns by trying things out, like playing a video game. If it does something right, it gets a reward. It If it does something wrong, it gets a punishment. Over time, it learns the best strategy. This is how AlphaGo, the AI that beat the World Chess Championship, was trained. So that we already talked in the first video. Today we are going to focus only on first two, supervised and unsupervised learning. Okay, so let's start. What exactly supervised learning? Supervised learning is when we train a machine learning model using labeled data. This means every piece of training data has already been given a correct answers or labeled by human expert. Let me give you the simplest possible analogy. Imagine you are a student preparing for an exam. Your teacher gives you 1,000 practice questions, and crucially, the answer is key is also provided. You study the questions and the answers together. After going through all 1,000 questions, you start to understand the pattern. You learn what kind of question leads to what kind of answers. This is exactly how supervised learning works. We give the machine thousand or even millions of examples with the correct answers already attached, and the machine learns the pattern between the input and the output. Now let me walk you through four steps process you can see on the slide. We collect input data. For example, we collect 50,000 photos of cats and dogs. We attach labels to each photo. For every cat photo, we write cat. For every dog photo, we write dog. These labels are the correct answers. The model trains, the algorithm goes through all 50,000 photos with their labels and it starts to learn. Okay, when I see pointed ears and whiskers, that is usually a cat. When I see floppy ears and a longer snout, that is usually a dog. Now we show the trained model a brand new photo it has never seen before, and it correctly identifies whether it's a cat or a dog. This entire process from label data to predictions is supervised learning. Now let's talk about more real life examples, right? Email spam detection. The model is trained on thousands of emails labeled spam or not spam. It learns words like free money, click here, you have won a prize tend to appear in spam. When your new email arrives, it predicts spam or not. Medical diagnosis. The model is trained on thousands of patient X-ray labeled cancer or no cancer by doctors. It learns the visual patterns of tumors. When a new X-ray comes in, the AI helps the doctor make a faster, more accurate diagnosis. Credit card approval. Banks train models on millions of past loan applications labeled approved or rejected. The model learns patterns, income level of candidate, credit history, existing debts, and predicts whether new applicant should be approved or not. Voice recognition. Apple's Siri is trained on millions of audio clips labeled with the exact words spoken. It learns what each word sounds like, so when you speak, it can describe your words accurately. Sentiment analysis. Companies like Amazon, Flipkart train models on thousands of product reviews labeled positive, negative, or neutral. The model learns to read new reviews and automatically detect customer sentiment. Now that we know what supervised learning is, let's go one level deeper. There are two main types of supervised learning problems: classification and regression. This is very important to understand. Classification is when the model predicts a category, is called a class or label. The output is always one of a fixed set of operations. The answer is not a number, it's a name or category. I would like to share just normal example so that everyone can remember. So category data, right? So male or female, colors, these are also categories. So yeah, that's what about category. Okay. So here are the most common real world classification examples. Email spam or not spam. Two categories. The model reads your email, puts you it in inbox or spam folder. Gmail processes around 100 billion emails per day using this. Medical diagnosis. Is the tumor malignant, dangerous, or harmless? This is a life-saving application or of classification. AI models trained on medical images can now match or even outperform human radiologists. Image recognition. Is the photo a cat, a dog, a bird, or a car? Facebook's face recognition tags your friends in photos using classification. Loan approval. Should this customer's loan be approved or rejected based on salary, credit score, existing debt, employment history? Disease prediction. Does this patient have diabetes or not based on blood sugar, BMI, age, family history? Fake news detection. Is this news article real or fake? Social media platforms use this to reduce misinformation. Handwriting recognition. What digits 0 to 9 is written? Is this image used in postal services to automatically read pin codes? Product quality control. In factories, cameras check if manufactured product has defects or is a good to ship. Now we covered classification. Now we are going to talk about regression. Regression is when the model predicts a continuous number, not a category. The output can be any number on a scale, like a price, a temperature, a score, a percentage, numerical data. Here are the most common real world regression examples. House price prediction. Given a house with 3 bedrooms, 2 bathrooms, 1200 square feet in Hyderabad, what is the price? The model outputs a number like 85 lakhs. Stock price prediction. Given the company's last 30 days of stock data, what will be the price tomorrow? Output like 2450. Student score prediction. Given how many hours a student studied, how many classes they attended, what will their final exam score be? Output can be 78 marks, like based on the given data. Car resale price. Given a car that is 5-year old, has done 80,000 kilometer, is a Honda City, what is its resale value today? Output can be 7.2 lakhs. These are all examples. Weather forecasting. Given today's temperature, humidity, wind speed, what will the temperature be tomorrow? So output can be 34 degrees Celsius or 35 degrees Celsius, what based on the today's data. Electricity demand prediction. Power companies predict how much electricity a city will need tomorrow so they don't overproduce or underproduce. Uber surge pricing. Uber's model predicts how much demand there will be for rides in your area at a particular time and sets the price dynamically, not statically. So the key difference is simple. Classification predicts a label, category. In other words, regression predicts a number, value. So think classification like class or category, regression just like a result or a number. Now let's look at the most important algorithms, the actual tools, the data scientists use to build supervised learning models. You don't need to understand mathematics behind these right now, just understand what each one is good at and where it is used. So, starts with linear regression. This is the simplest algorithm. It draws a straight line through your data points. You uses that line to make predictions. It is used when the output is a number. As we discussed in the previous slide, one of the examples, house price prediction, right? Next, logistic regression. Despite having the word regression in its name, logistic regression is actually used for classification. Specifically, when there are only two possible outputs, yes or no, true, false, or zero. It outputs a probably a number between 0 and 1. If the probability is above 0.5, it predicts S. If below 0.5, it predicts no. Example, will this customer click on this advertisement? Output 0. Let's say probability 0.78. So obviously it's yes. Uh, so yes, they probably will check. Example, another example is this email spam. If the model says probability 0.91, it is very likely spam. Put it in the spam folder. And decision tree. A decision tree makes predictions by asking a series of yes or no questions like a flowchart. At, a, at each step, it splits the data based on condition. Think of it like a game of 20 questions. Is the person older than 30? Yes. Do they have study income? No. Then reject the loan amount. That's how it decides. Another example, doctors use decision trees in diagnosis. Does the patient have fever? Is it above 103 degree Fahrenheit? Do they have a rash? So, possible diagnosis. Next, we are moving to a random forest. A random forest is simply a collection of many decision trees all working together. Each tree gives a vote and the majority vote wins. This is called an ensemble method. It's more accurate than single decision tree and it handles noisy data better. For example, instead of one doctor giving a diagnosis, imagine 100 doctors each independently examining the patient and voting. The majority opinion is likely to be more accurate. There is exactly what a random forest does. And another example in used in Zomato and Swiggy to predict delivery time based on traffic, restaurant preparation time, distance, weather. Next, we are moving to support vector machine. Support vector machine draws the best possible boundary line called a hyperplane between two classes. It finds the line that has maximum gap between two groups. Example, classifying handwritten digits for India Post. Is this handwritten number a 4 or a 9? Support vector machine draws the boundary that best separates them. Used in bioinformatics to classify proteins. Is this protein dangerous or harmless? And another example, face recognition. We are now moving to new neural networks, deep learning. Neural networks are the most powerful supervised learning tool today. They are inspired by the human brain. In fact, millions of connected nodes organized in layers. They are what powers ChatGPT, image recognition, speech to text, and self-driving cars. Let's talk about few examples in neural networks. Google Translate uses neural networks trained on billions of translated sentences pairs labeled data to translate between 130 plus languages. And YouTube uses neural network to classify every frame of uploaded video, checking for violence, adult content, or copyright violations automatically in real time. So we have spoken about unsupervised. Now let's talk about what is unsupervised learning. The algorithm is trained on unlabeled data. There are no pre-given answers. The model discovers hidden patterns, groupings, and structure all by itself. Great. So now we have a solid understanding of supervised learning. We'll continue to learning in unsupervised learning. In other words, unsupervised learning is when we give the model data that has no labels, no answers, no correct output. The model has to explore the data completely on its own. It has to find hidden structures and patterns that we don't even know exist. So let me give you an analogy. Imagine you just moved to a new city, say Bengaluru, and you know absolutely nobody. You start going to social event and meetups. Over time, without anyone telling you, you start to notice patterns. You start grouping people naturally. These people are all from the tech industry. These people are all artists. These people are all fitness enthusiasts. Nobody told you to create these groups. You discovered them yourself. That is exactly what unsupervised learning does. It takes raw data and discovers natural groupings and patterns that were invisible before. So let's go step by step. Okay. Raw data. We give the model 1 million customer purchase records from Flipkart, no labels, no categories, just raw transactions. Model explores, the algorithm starts analyzing the data. Looks it looks at patterns, who buys that, how often, how much they spend, what time of day. Then step 3, groups formed. Without any human guidance, the algorithm discovers that there are four distinct types of customers. Group 1, high spenders who buy electronics. Group 2, budget shoppers who buy only during sales. Group 3, frequent buyers of groceries and household items. Lastly, Group 4, fashion conscious buyers. Business insight. Now Flipkart can send a targeted marketing to each group. No more generic. Sale on everything emails. Now you get personalized recommendations based on your group. The entire process from raw data to discover patterns is unsupervised learning. Now let's try to talk about real examples. Social media like Facebook and Instagram don't label their users. Instead, unsupervised models group users by interest, behavior, and engagement patterns, then show ads accordingly. Now, music streaming. Spotify doesn't label its 600 million users, but it clusters them by listening patterns and uses that to create personalized playlist like Discover Weekly. Right? We get that pop up. Your mix is unique to you. Your mix is unique to you. Last example for this unsupervised learning news aggregation. Google News groups thousands of news articles from different sources about the same event together without being told what each article is about. It discovers the topics automatically. Moving to types of unsupervised learning. Now, unsupervised learning can be applied in three major ways: clustering, dimensionality reduction, and anomaly detection. Let me explain each one. Clustering is most common type of unsupervised learning. The goal is to group similar data points together into clusters. When items in the same cluster are more similar to each other than to items in other clusters. Customer segmentation as an example, an e-commerce company groups its millions of customers into clusters based on purchasing behavior. Cluster A, young college students buying budget items. Cluster B, working professionals buying premium products. Cluster C, parents buying children's items. The company then tailors marketing for each cluster separately. Now, document clustering. Google clusters millions of news articles into topics: sports, politics, technology, entertainment without reading each one. It does this by finding similar words and phrases. Medical imaging. Radiologists use clustering to group similar looking tumors images together. This helps identify new subtypes of diseases that were not previously known. Social network analysis. LinkedIn clusters users into professional communities, data scientists, HR professionals, startup founders to suggest better connections. Now, let's talk about dimensionality reduction. This sounds complex, but the idea is simple. Imagine your dataset has 500 features like columns of data. For each customer, age, gender, location, purchase history, browsing time, device type, and hundreds more. Working with 500 features is very slow and confusing as well, right? Dimensionality reduction compresses all those 500 features into just two or three key features while keeping most of the important information. It's like squeezing a huge zip file. The size gets smaller, but the important content is still there. So, face recognition as an example. A photo of a face has thousands of pixels. Principal component analysis, called PCA, reduces all those pixels into a small set of key measurements. Distance between eyes, nose shape, jawline, making recognition much faster and more accurate. Netflix recommendation. Netflix has data on thousands of movie features, genre, director, cast, length, language, mood. So PCA reduces these into a handful of key taste dimensions that predicts what you will like it, what you like next, and gen research. Scientists analyze thousands of genes at once. Dimensionality reduction helps them find the 10-20 genes that are most relevant to a specific disease out of thousands. Anomaly detection. Anomaly detection is the task of finding data points that are very different from everything else. The outliers, the abnormal ones. The model first learns what normal looks like. Then when something doesn't match the normal pattern, it raises a flag like credit card fraud detection. Your card is normally used in Hyderabad for small purchases. Suddenly a transaction appears from Tokyo for 2 lakhs. The anomaly detection model flags it immediately and your bank calls you. Network security. A company servers normally handle 10,000 requests per day. Suddenly 2 million requests come in from one IP address in 5 minutes. That is an anomaly, likely a hacking attempt. The system blocks it automatically. Industrial manufacturing. Sensors on a factory machines record vibration, temperature, and noise. If a machine starts vibrating 3x more than a normal, the anomaly detection system alerts the engineer before the machine breaks down completely. Healthcare monitoring. Hospitals use anomaly detection in patient monitoring system. If a patient's heart rate suddenly spikes or drops outside the normal range, the system alerts the nurse immediately. Now let's talk about popular unsupervised learning algorithms. Just like supervised learning had its algorithms, unsupervised learning also has a set of powerful algorithms. Let me walk you through the most important ones again. K means clustering. So K means is the most popular clustering algorithm You tell it how many groups you want to. Let's say k equals 3, and it automatically divides your data into 3 categories. It works by randomly placing 3 center points, assigning each data point to nearest center, then moving the centers to the middle of their assigned points and repeating until the clusters stabilize. For instance, a mobile phone company uses K means to group 10 million users into 3 clusters: heavy users, moderate users, and light users, and offers different data plans to each group. And another example we can say Zomato uses K means to cluster restaurants by cuisine type and price range to make food discovery easier. Hierarchical clustering. Unlike K means where you decide K upfront, hierarchical clustering builds a tree structure called dendrogram that shows how all data points are related to each other at different levels. Example, in biology, scientists group thousands of animal species into a hierarchy, and reptiles, reptiles, birds, based on DNA similarity. This is done with hierarchical clustering. Another example we can say market researchers cluster countries into a region based on economic indicators without deciding upfront how many regions there should be. DB scan, density based spatial clustering, finds clusters of any shape. Example, geospatial hotspot detection. It's a great at finding clusters of irregular shapes and smart enough to identify outliers that don't belong to any cluster. For example, Uber uses DB scan to find geographical hotspot areas of the city where ride demand is highest. The clusters are irregularly shaped based on roads and neighborhoods. Another example, scientists studying earthquake patterns use DB scan to find dense cluster of seismic activity. These clusters identify fault lines. PCA, Principal Component Analysis. PCA is the most popular dimensionality reduction technique. It takes data with many features and compresses it into a fewer dimensions while preserving the most important patterns. There are a couple of examples that we can talk, like imagine a data set about people with 50 features: height, weight, shoe size, waist size, chest size, etc. So PCA might reduce this to just 2 dimensions: overall body size and body shape. Now you can plot everyone on a 2D graph and see patterns clearly. Another example, stock market analysis. Instead of tracking 500 stock prices individually, PCA reduces them to 5 key market directors that explain most of the price movement. Auto encoders. An autoencoder is a type of neural network that learns to compress data into a smaller representation and then reconstruct it back. The compressed middle part captures the most essential features. So, couple of examples that we can talk. Image denoising. Old damaged photographs can be cleaned and restored using autoencoders trained to separate signal from noise. And Netflix and YouTube use encoders to detect unusual user behavior. Accounts that Suddenly watch hundreds of video in 1 hour might be bots. Lastly, a priori or association rules mining. The algorithm finds items that frequently appear together in a dataset. It discovers associations. If a cluster buys X, then also tend to buy Y. Amazon's customer who bought this also bought feature is powered by association rule mining. If millions of people who bought a laptop also bought a laptop bag, the algorithm discovers this pattern automatically. Supermarkets discovered that people who buy diapers on Friday evenings also tend to buy beer. This surprising insight was discovered by association rule mining, and stores now place uh, diapers and beers closer together. This happens in America actually. Yeah. Last example, medical research. Doctors use it to find which symptoms frequently appear together, helping discover new disease patterns. Now let's put everything we have learned side by side in one clear comparison table. So try to take a screenshot as we are discussing here. So supervised learning versus unsupervised learning. So when data is always labeled with answers, but coming to unsupervised learning, unlabeled. So goal of unsupervised learning predict output for new data. Coming when it comes to unsupervised learning, discover hidden patterns, complexity, similar simpler to evaluate, more complex, subjective as well. Accuracy measurable in terms of percentages, hard to measure directly. Human input needs labeled training data. In unsupervised learning, minimal human input needed. Speed, supervised learning slow, labeling is costly, faster, no labeling is required. Examples, classification like we discussed, categories, right? Regression and always numerical data. And unsupervised learning, clustering, PCA anomaly. Real case, email spam, medical diagnosis. In unsupervised learning, customer segment recommendations. Popular algos, random forest, SVM, neural net, K-means, DB scan, auto encoders. The most important difference to remember in this, supervised learning knows what it's looking for, the answer is given in the training data. Unsupervised learning does not know what it's looking for, it discovers patterns by itself. Other words to remember, supervised learning is like a student with an answer key. Unsupervised learning is like a detective with no clues, just raw evidence. Let's now look at how both techniques are used simultaneously in the same industry and sometimes in the same product. Because in the real world, it's not always one or the other. The best AI systems combines both. Email, like supervised learning, Gmail was trained on millions of emails labeled as spam or not spam by users. Now it correctly filters over 99.9% of spam. Google claims it blocks 100 million spam emails per day. Unsupervised learning, Gmail automatically discovers categories in your inbox, primarily social promotions update without anyone telling it what those categories are. It also clusters similar threads together. So yeah, so in the Gmail case, now we are witnessed that Gmail uses both supervised and unsupervised learning. Now let's talk an example in Amazon and Flipkart e-commerce, right? So supervised learning. Will this customer buy this product? Trained on millions of past purchase records with yes or no labels. Used to decide which product to show at the top of search results. Unsupervised learning. Customer segmentation. Grouping shoppers into tags, deal hunters, premium buyers, occasional shoppers without any labels. Using only purchase history data enables personalized marketing. Amazon uses both together. First, cluster customers and then predict what each cluster will buy next. This combination makes recommendations extremely accurate. So in healthcare, trained on thousands of labeled MRI scans, tumor or new tumor to help radiologists detect cancer earlier. Studies show AI can detect some cancers with 94% accuracy versus 88% for human doctors. Unsupervised learning. Scientists feed in generic data of 10,000 cancer patients with no labels. The model discovers that are actually five distinct subtypes of the cancer. A discovery that changes how treatment is done. Netflix and streaming. Supervised learning. Will you rate this movie 4 star or above? Trained on your past ratings. Netflix predicts your rating before you even watch and shows your movies it predicts you will rate highly. Unsupervised learning. Netflix clusters its 260 million users into thousands of micro communities. People who love Korean crime dramas and also like British comedies. These clusters are discovered, not defined by humans. Netflix has reportedly identified over 2000 taste communities using supervised learning. No human sat down and named them all. The algorithm discovered them. Bank, banking and finance. Supervised learning. Will this loan be repaid? Trained on millions of historical loan records with outcomes repaid or defaulted. Enables instant loan decisions in apps like Slice, Navi, and CreditBee. These are all loan apps, mobile loan apps. Unsupervised learning, fraud detection. The model learns what normal transaction look like for you. Any transaction that deviates significantly, different country, unusual amount, unusual time is flagged as a potential anomaly. Visa processes over 65,000 transactions per second. Their fraud detection system, unsupervised anomaly detection, analyzes each transaction in under 300 milliseconds and flags suspicious ones automatically. Self-driving cars, Tesla and Waymo. Supervised learning, object detection. The car's cameras see an image and classify every object: pedestrian, traffic light, stop sign, other car, cyclist, trained on millions of labeled images. Unsupervised learning, clustering road scenarios. The car's AI groups similar driving situations, rainy highway, crowded city intersection, parking lot, and learns how to behave in each cluster of scenario. So when should you use which? All right. So now the big practical question. As a developer, data scientist, or someone building an AI product, how do you decide which type to use, right? Here is simple decision framework. So we all should remember. So when we choose supervised learning, you have a clear specific output you want to predict, a label or a number. Your training data is already labeled, or you have the budget to get it labeled by experts. You want to measure accuracy easily. You can compare predictions to known correct answers. Your problem is classification, predict a category, or regression, predict a number. Practical examples of when to use supervised learning. I want to build a system that detects whether a skin lesion is cancerous. Clear label cancer or not cancer, use supervised learning. I want to predict how many units of product X will sell next month. Predict a number, use regression supervisor. I want a chatbot that classifies customers' complaints into categories. Predict a category, use classification supervisor. Choose unsupervised learning when you have a large amount of raw unlabeled data and labeling it to too expensive or impossible. You want to explore and discover patterns you don't yet know about. Your goal is to group similar items together. Customer segments, document topics, gene types. You want to detect anomalies or outliers without knowing in advance what those anomalies look like. You want to compress data, reduce many features to a few while keeping key information. So practically, I have 5 million customer records and I want to understand who my different customer types are. No labels needed. Use clustering unsupervised. I want to find unusual transaction in my payment system that might be fraud. No labels. Detect outliers. Use anomaly detection unsupervised. Last, I have 1,000 features in my dataset and my model is too slow. I want to reduce them. Use dimensionality reduction unsupervised. So ultimately, can you use both together? Absolutely, yes. In fact, of the best real world AI systems combine both. First, use unsupervised learning to cluster your data into groups, then use supervised learning within each group to make better predictions. This is called semi supervised learning or a cluster then classify approach. A hospital first uses unsupervised learning to discover that its patients naturally fall into four subgroups based on test results. Then it uses separate supervised model for each subgroup to predict the best treatment, leading to much better outcomes than one general model. All right, we are almost done. Let me quickly summarize everything we covered in this video. These are four key takeaways. Supervised learning. Supervised learning uses labeled data where the correct answers are already provided. The model learns to map inputs to outputs. It has two types: classification, predicts a category, and regression, predicts a number. Common algorithms include linear regression, random forest, SVM, and neural networks. Real world uses spam detection, house page prediction, medical diagnosis, face recognition. Unsupervised learning. Unsupervised learning uses unlabeled data and the model discovers hidden patterns on its own. It has three types: clustering, like groups similar items, dimensionality reduction, compresses data, and anomaly detection finds unusual data points. Common algorithms include k-means, dbscan, pca, auto encounters, real world uses, customer segmentation, fraud detection, recommendation system, data compression. So finally, the key difference is supervised learning is like a student with an answer key. It knows what correct answer is. Unsupervised learning is like a detective with no clues. It discovers the patterns by itself. Supervised learning is easier to evaluate. Unsupervised learning is cheaper to run because it doesn't need expensive labeled data. Real world impact. Both types of learning are used every single day in products you already using Gmail, Netflix, Amazon, your bank app, Spotify, Google Maps, and hundreds more. Every time you see a smart recommendation or your bank catches a fraud, this is machine learning at work. So in the next video, we will cover reinforcement learning. This is type of machine learning to use train gaming, playing AIs, robots, and systems behind ChatGPT. It is a fascinating topics, so make sure you don't miss it. Thank you. Yeah, that's the wrap up on today's video. We covered a lot today. I know it's quite overwhelming for you, even for me also. Two of the most important and widely used concepts in all of machine learning. If you made it all of the way to end of this video, thank you so much. That tells me you are serious about learning AI like me, and I really appreciate that. I want to ask just one thing. If you learn something new today, anything at all, so I would like to give you a thumbs up for all of you. So thank you so much for watching. Thanks for your patience. See you in the next video. Take care.